Good day everyone. Today me and my teammates would like to present about our case study, which title is Lakshmi's Daily Fitness of Me. Introduction. Statistics, which is just a simple word for numerical data, is a branch of mathematics that primarily deals with a gathering, tabulating, and analysis of numerical data. It is essentially a type of mathematical analysis that creates a set of experimental data or investigation of real life by employing various quantitative models. The diagram shows type of statistics, which is descriptive statistics and inferential statistics. The descriptive statistics are divided to two types, which is measure of central tendency and measure of variability. The measure of central tendency is mean, mode, and median. And then the measure of variability is range, variance, and dispersion. Objectives of this case study is to collect the required data for the case study assignment. And then the second one is to comprehend the subject that the students learn about in chapter 1 through chapter 6. And then the number 3 is to conduct the calculation using the data you have collected. Case study. A student in May wanted to determine how active she was over the period of 30 days. She kept a daily fitness journal and applied fundamental statistical theory and methods to track her improvement and future records. The information was utilized to calculate basic linear regression, estimate hypothesis testing, sampling distribution, probability distribution, and random variable. According to studies, wearing a fitness tracker on a regular basis, a gadget that records your movements, such those from smartphone apps, can boost the number of steps we take each day. In this instance, we decide to monitor Lakshmi's everyday fitness throughout a 30-day period. The information will include distance, steps, and calories. This slide shows about the data that we collected for our case study. Chapter 1. Discrete random variable, probability distribution function. So the table shows about the number of steps during odd number days, which is x. Before we start our calculation, uh, we, we need to separate all the data which we collected into 5 classes. And then the next step is need to find the frequency, and then the next step is need to find the probability value. So we can use frequency over total frequency formula to find the probability value. And then next step is after we collected all the data, so we can do the histogram graph by using the probability value. So the second diagram shows about the probability of number of steps during odd number days, x. This slide also same step and repeated as previous slide, but this time uh, the table shows about the number of steps during even number days, which is y. And then the before we start our calculation, as usual, we need to separate all the data into 5 classes, and then need to find the frequency value. And then the next step is I need to find the probability value. And then the second diagram shows about the probability of number of steps during even numbers, which is y. The next slide shows about the cumulative distribution function step. Cumulative distribution function of discrete random variable for steps taken during odd numbers days is so the value that we get is 1. And then for second one is cumulative distribution function of discrete random variable for steps taken during even number days. So the value get is as same, which is number 1. So the next step is expected value and variance. By referring the table, we need to find the mean, variance, and standard deviation of the discrete random variable. So, in this slide, we need to find the total mean, variance, and standard deviation. So, the first one is mean. So, for mean, we need to multiple the frequency and probability value. So, we can get the 4.71 value. Then the next one is EX square. So we need to calculate the frequency and times by EX value. So we can get the 24.51 value. So the second step is variance. Variance is 24.51 minus by 4.71 square. So we can get the 2.3259 value. And then the standard deviation, we need to square root the 2.3259 value. So the final answer is 1.5251. This slide also showing the same step as previous slide, but that slide shows about the x, and then this slide shows about the y. So the formula for this, for find the mean, is frequency times by probability, and then we can get the 3.37 value. And then the next step is we need to multiply frequency and EX value, so we can get the 12.89 value. And then the next step is find the variance. So as usual, we need to minus 12.89 into 3.37 square. So the answer is 1.5331. So the last step is find the standard deviation. So 1.5331 square root. So the final answer is 1.2382.
So I'll be explaining the part chapter 2, Poisson probability distribution application. So the data that I'll be using for the 30 days will be the distance for this part of this chapter. And the question given is Lechumi's daily fitness metrics for May are displayed in the table above, along with the total distance she covered each day from May 1 through May 30. 30 days worth of data are collected. Every day's data collection is different and inconsistent, as seen in the table. With the use of the data, a Poisson distribution experiment will be conducted. So for this question, I've ready 4 questions for this chapter 2. So in the case of Lechumi's daily fitness in May, suppose that the distance in kilometer follows a Poisson distribution with a mean of 2.917 kilometer per day. Find the probability that she made exactly 5 kilometer distance in a day. So the solution for this question will be very straightforward and will be the Poisson distribution formula, which is probability x equals to exponent to the power of negative nu times nu to the power of x over x factorial. The x value would be vary to 0, 1, 2, 3, and etc. Thus, the calculation is probability x equals to 5 equals to exponent to the power of negative 2.917 times 2.917 to the power of 5 over factorial 5 factorial equals to the 0.0952. For question B, find the probability that she made 10-kilometer distance in 5 days. Since 1 day is equals to 2.917 kilometer, thus for 5 days, the new average is nu equals to 5 days times 2.917 kilometer. It's equals to 14.585 kilometer. Then the x the new X probability will be 14.585. Thus, this will follow the Poisson distribution formula. Probability X equals to 10 equals to exponent to the power of 14.585 times 14.585 to the power of 10 divided by 10 factorial equals to 0.0556. For question C, find the probability that she made at least 1 kilometer distance in 2 days. Since 1 day is equals to 2.917 kilometer, thus for 2 days, the new average is new equals to 2 days times 2.917 kilometer per day equals to 5.834. Then the X probability will be 5.834. Thus, this will follow the Poisson distribution formula. Px more than or equal to 1 equals to 1 minus Px equals to 0 equals to 1 minus exponent to the power of negative 5.834 times 5.834 to the power of 0 over factorial 0 factorial equals to 0.9970. For question D, find the value of standard deviation. Standard deviation, or sigma, for a Poisson distribution, the variance is given by sigma square equals to nu. Thus, to find the standard deviation, the mean will be square rooted. So, for example, the solution will be sigma equals to square root nu. Sigma equals to square root 2.917, and the answer will be 1.708.
Hi, Assalamualaikum. My name is Muhammad Aris bin Ismail, CN2103882. I'm going to continue with Chapter 3, Sampling Distribution Application. As we can see at Table 5.0 is the total calories per day in May 2023. As for the Table 5.1, we can see the range total calorie burned. At the right side, we can see the frequency. Okay, we can continue with question. One experiment involved tracking a student's daily fitness by tracking total calories burned over the course of 30 days. The Apple Fitness app is used to capture all calorie data. The probability distribution for the random variable x, which represent the frequency of range total calories burned per day, as is follow. Okay, from the table, we know that x is the frequency, which is 5, 10, 7, 0, and 1. Probability of x is 0.07, 0.03, 0.03, 0.03, and 0.1. Question A. Find the population mean and variance. So, as we can see, the other symbol that we can use for mean is x bar. Okay, mean is frequency divided by probability. So we get the total mean is 0.96. Okay, as for the variance, this is the formula of the variance. Variance to the power of 2 is equal to the probability kurungan x to the power of 2 kurungan minus kurungan probability kurungan x and kurungan to the power of 2. And the total probability of x to the power of 2, we get 6.32. And we put the value of the mean, and the probability to the formula of variance, and variance to the power of 2 is equal to 6.32 minus 0.96, and we get the the total is 5.36. And the 5.36, um okay, so the value we have to square root, and we get the 2.3152. Okay, for question B, we must find the sample mean and variance for random sample of 1255 calories. Okay, given the n is 30 and the mean is 1255 and the variance 0.96 and the standard deviation. Okay, okay, sorry for my mistakes. Oh, okay. For the mean, as we know, is the 0.96, and the variance is 5.36. Okay. Step one, we must find the mean sample of mean, which is x bar. Mean x bar is equal to mean is equal to 0.96. And step two, we must put into the formula, which is the standard deviation per with the square root of n. We get the total is 0.4, and we get 0.4227. Okay, for question C, calculate the probability if the average calories in 21 days will be less than 1.5. So, the probability of the frequency x 1.5. So, um, from the question B, we continue with step 3, and we get the value, and we continue with step 4. We put into this formula, and we get the distribution value for the probability is 0.103. And from this statistic table 3, the distribution value of the probability, we get 1.28 for Z. Okay, next we continue with chapter 4, which is estimation application. Down here we can see the table shows that the daily working step of student A in May 2023. You can see the total day is 30 days, and distance, and we can see the mean, which is x bar, and at the right side is dx minus x bar power of 2. Okay, as we can see, the total distance for 30 days is 87.52 kilometers, and at the right side, the total is 151.5789. Is the daily walking step of student A in May 2023. 6.1 Confidence interval for single mean. 6.1.1 large sample n, which is 30 days, or variant known. Find the estimates for mean, variance, and standard deviation of the daily kilometers of walking for student A, which is Lechumi, in May 2023. First, we must find the sample mean, which is x bar, and the right side is the formula. Total number of distance over n, which is days, total number of days, and we put the value of total distance, 87.52 over 30 days, and we get 2.917. For the variance, as power negative, power as power of 2. The right side is the total x minus x bar to the power of 2 over n. We put the value and we get 5.053. For the standard deviation, we can see the formula at the right, which is the square root of total x minus x bar to the power of 2 over n. So we must square root the variance value and we get 2.248 for the standard deviation. Okay, next, the daily distance of walking for student A, which is Lechumi, in May 2023 were recorded in the following tables. So we can see the total that we recorded is 30 days. The average of median daily walking distance is regularly distributed with a standard deviation of 2.25. A sample mean of 2.92 was chosen at random from the data of the days 30, which is 30 day. Estimate the population mean using the 95% confidence interval. Okay, we continue. So alpha we must divide it by 2, we get 0.025. To find the z value, and we get the value of 1.96. We put it into the formula x bar plus minus zn over za over 2 s over the square root of n. So from the data given, we just put the value in the formula. The value of x bar 2.92 minus plus minus 1.96 and the variance as 2.25 over the square root of n, which is 30 days. And we get the range of the population mean of daily distance of walking for student A, Lechumi, is between 2.1148 kilometers and 3.7252 kilometers. Okay, we continue with 6.2, confident interval for ration variance. The question, two data sets for student A and student B are assumed to have normal distribution, and mean A, the variance to the power of 2A, and n, mean B, variance power of 2B. A random draw of 12 and 15 data of distance respectively from student A and student B resulted in the following data. We can see the data for the student A and student B. Student B, we just predict that the data are commonly the same, and a random sample of 12 days of distance for student A is selected and found to have sample standard deviation of 2.4 kilometers. Meanwhile, a random sample of 15 days of distance for student B is selected and found to have sample standard deviation of 1.9 kilometers. Construct of Construct a 95% confidence interval for the ratio population variance. As we can see, the ratio population variance formula. Okay, we continue with the solution. We from the data A equal to 12 and the data B equal to 15. The variance A is equal to 2.4 to the power of 2. Variance B is 1.9 to the power of 2. VA is equal to NA minus 1 equal to 12 minus 1 equal to 11. For VB is equal to NB total of B minus 1. We get 15 minus 1 and the value is 14. Alpha 1 minus 0.5, we get 0.05. So if we want to put to the formula, we must divide it by 2 and we get 0.025. And then okay, as we know, the 0.95 is the confident intervals, and we need to find the ratio population variance. Okay, for the F 0.0025. Okay, continue with the ratio population variance formula. From the value for A 0.3231 and the value for B 2.4048, we put the two value into the formula and we get the confident that the ratio population variance is between the 0.5155 and 3.837.
Next is Chapter 5, which is the hypothesis testing application. Hypothesis testing is a statistical method used to make inference or draw conclusion about a population based on a sample of data. Null hypothesis is the default or initial assumption that there is no effect or no difference in the population, while the alternative hypothesis states your research prediction of an effect or relation, because an alternative hypothesis is a statement that opposes the null hypothesis. As we can see here, these are the data of total calories burned by Lakshmi on May 2023, where it consists of days, total calories, and a formula of x minus x bar square. The x is the total calories each, and the x bar is the sample mean that we are going to find later. And this data is total up, where the total value of total calories and formula of x minus x bar square is used later to find the sample mean, standard deviation, and the variance. As stated before, these are the sample mean, variance, and standard deviation, where the sample mean is equals to the summation of x over n, where the summation of x is the total calories, that is 39,563 over the n value of 30, and you will get a sample mean of 1318.77. Going on to the variance with the formula of summation of x minus x bar square over n, where the x minus x bar square total is 165,503 over the n value of 30, and you will get a variance of 5,516.77. And the final one will be the standard derivation. Standard derivation is a square root of variance, where you will get a value of 74.27. This is the question, and it states that in May 2023, a random sample of Lakshmi's daily calories expenditure was collected. The average daily calorie expenditure for this month was 1,318.77 calories. With a standard deviation of 74.27 calories, test the hypothesis at the 95% of confidence level if the calories burned in the next month are greater than 1,300 calories. So for the first solution, we must get the data from the table of data and the question, and we found out that n is equals to 30. The standard derivation is 74.27 calories. The confidence level is 95%, and we divide by 100 to get the point form of 0.95. The sample mean is equals to 1318.77 calories. And as stated in the question, next month is greater than 1300 calories, so it will become mu more than 1300 calories. So for the first step, we are going to write the original claim and identify the null hypothesis and the alternative hypothesis. The null hypothesis we get is mu is equals to 1300, and the alternative hypothesis is mu more than 1300. For step 2, we will be searching the right tail test by using n is equals to 30, standard derivation of 74.27 calories, and a confidence level of 0.95. This confidence level will be then converted into a significant level, where the significant level will be placed on the probability and statistic table and will be searched for the z value, that is the z critical. So the formula of significant level is 1 minus by confidence level. So in this value, we will be minusing 1 with 0.95 to get a significant level of 0.05. Then later, we will be searching the 0.05 in the probability and statistic table to find the percentage point of the normal distribution. Whereas I show in the arrow and the box, you can see that 0.05 is equals to the z value of 1.6449. Therefore, the z critical value will be 1.6449. Next is step 3, that is compute the test statistic, where we are going to find the z-test and do drawing of a normal distribution. The z-test as a formula of x bar minus by hypothesized mu over the standard derivation divided by square root of n, and place all the values in the formula, and you will get a z-test of 1.3842. For the normal distribution drawing, we will be drawing a normal distribution and shade the right tail of the distribution, because as said in the question, it is greater than 1300 calories, where the shaded region of the right hand side will be till the z critical value of 1.645 or 1.6449. And as seen here, the z-test is smaller than the z-critical, causing it to be not rejected hypothesis because it is not in the shaded region. The shaded region is the region said to be the rejection region. On step 4 states the analysis of rejection of the null hypothesis, where the statement states that the test value is 1.3842, which is less than the critical value, which is 1.6449, makes the decision it does not reject the null hypothesis. Going on to the final step, which is the conclusion of null hypothesis. The conclusion states there is not enough evidence to support the claim that the mean calories burned by Lakshmi in May 2023 is greater than 1,300 calories.
Hi, Assalamualaikum. My name is Iqbal Shazwan bin Muhammad Nasir. My metric number is 200, CN200-269. Today I will present about chapter 6, which is simple linear regression application. So as you can see, there is a table given, which is distance and total calorie. For distance, we identify is x, and total calorie is y. So distance is independent and total calorie is dependent. Okay, this is our graph, which is distance and calories by Lakshmi in May. We have plot each point based on our table, which is previous slide. So for distance is x-axis, and for calorie is y-axis. Okay, before we go to question B, we must get a value of x bar, total x square, y bar, total y square, and total xy. So first of all, we must calculate. We insert a value of x, which is distance, and y is calorie. We insert to calculator, then we get the value. Okay, for equation for the line best fit, which is y maximum equal to intercept of y plus slope of the line multiplied by x. So for slope of the line equal to SSY divided by SSX. So that is a equation for SSY equal to total x multiplied by y minus by 1 divided by n, then multiply by total x and multiply by total y. So for the value of total xy is 120,365.16 minus by 1 divided by our total n, which is 30, and you multiply by 87.52, then multiply by 39,563, then you will get SSY value. So for SSY value is 4946.701. Okay, so for SSX is equal to total x, then you minus by 1 divided by n, then multiply by total x power of 2. So for the value for SSX is 151.578. Okay, for uh, okay, for the value of slope of the line, this is the formula SSY divided by SSX. So for our value, SSY is 4946.0701 divided by 151.578. Then you will get 32.635. For intercept of y, equal to y maximum minus by slope of the line times by s maximum. So our value of y maximum is 1318.767 minus by 32.635. Then you times with 2.917, then you will get the value of intercept of y. For y maximum equal to intercept of y plus the slope of the line then times with x. So for our intercept of y is 1223.571 plus by 32.635, then you multiply by x, then you will get a y maximum. Okay, for next question, assume that several amount of calorie will be consumed every day. Add x equal to 30 to the equation derived from solution B. So this is equation of y maximum equal to intercept of y plus slope of the line. So you multiply by x, which is 7. So our intercept of y is 1223.571 plus by 32.635. Then you multiply by 7, you will get a y maximum, which is 1452.016. Okay, for question D, determine the Pearson correlation and determination coefficient. Analyze the outcome. Okay, for example, how to get a y predict. X is equal to 3.39. Then we insert into the equation, which is y equal to intercept of y plus slope of the line, then you multiply by 3.39, then you will get y predict. Okay, for coefficient determination, the coefficient of determination or R2 is range from 0 to 1. Describe how successfully a statistical model predict a result. The R2 rule uh, could be true of as the proportion of variation in the dependent variable that the statistical model forecast. The outcome is only partly predicted by the model. Okay, this is a equation to get a R2. R2 is equal to 1 minus by SSE divided by SYY. So 1 minus by SSE, which is our value of SSE, is negative 38.158. Then divide by SYY, which is 165,503.37. Then we will get R2, which is 1. Okay, for coefficient of a person, that is equation r equal to SXY divided by square root of SXX multiplied by SYY. So our SSY value, which is 4946.701, divide by square root of SSS, which is 151.578, then multiply with SYY, 165,503.37. So then you will get the value of R, which is 0.988.
So in conclusion, statistical methods are mathematical formulas, models, and procedures utilized in the statistical analysis of raw research data. Statistical approaches are used to extract information from research data and offer several methods of evaluating and reliability of research findings. Lechumi's daily fitness in the month of May 2023 is the system of phenomenon that the research and output are based on by calculating her daily fitness from her number of steps, converting them to kilometers. She is very active throughout the day because she walks and jogs frequently. The primary purpose of this study was to investigate everyday fitness over the month of May 2023. We were able to simply obtain the data from a fitness tracker and, as a result, fully comprehend all the chapters in the steps and distance in kilometers. We were relevant. We create relevant questions for each of the lecturer's chapter topics utilizing data to examine the data and draw wise conclusions. We made use of a number of statistical tools and procedures that we had learned about throughout the course. This case study has exhibits real-world statistical application and helps us understand basic statistical concepts and methodologies. Thank you.